Hello everyone. Today I want to talk about the concept of evolutionary processes. I feel it is a very good tool to analyze all kinds of interactive processes that are developing over time. And the best known of these is probably biologic evolution, which leads to the different species we see today. But it can also be applied to many other circumstances and situations. I want to start talking about some details which probably not always described correctly when it comes to biological evolution, but similarly also to other evolutionary processes. And I think the first one is that there's a tendency to kind of overlook that evolution is a very complex process where many different of the, in case of biology, of the organisms are actually interacting all the time and influencing each other's evolution all the time. So you might say, okay, I want to see how did some animal evolve, so you can make a line of, for example, how cats evolved. How this evolution was driven that led actually to our cat is quite complicated, because the whole environment is changing all the time as well. Like the animals that, for example, cats hunt are adapting to the fact that they're hunted by cats. At the same time, plant eaters, which probably cats usually hunt, are adapting to the changes of the plants around them. The plants around them, at the same time, are adapting to the fact that they are being eaten by those plant eaters, and they will adapt in some ways, looking for ways to protect themselves from animals that eat them, but also developing ways that actually where they can use such animals to spread their to use it to spread around their offspring in space, things like that. So it's a very complicated interacting system. All the animals will adapt, even if they don't eat plants, they will adapt to the fact how the plants give shadows, how large the plants are, how they look like, and everything, all the living organisms at the same time react to the geological environment. So they will adapt to what kind of ground there is where they are, and when they move on in space, they will adapt to other grounds, to other geologies, how much sun they're getting, how weather patterns change. So it's a constant process where things influence each other. And even if you look further, there's actually interesting geological evidence that the number of animals, or the number of plants in the history of the Earth led to changes in the percentage of oxygen in the air, and this again had effects on plant life and on animal life. And of course, since plants create oxygen, so they kind of also do some terraforming of the environment by doing that. And at the same time, animals, by breathing in the oxygen and kind of binding it again, they're also co-regulating the whole process. So if you look at it, it's a very complicated process where many things are influencing each other all the time, and then some things which are outside influences, like for example sun cycles, or which obviously will not be influenced by animals on Earth, but of course influence the animal and plant life on Earth. So whenever you think about evolution, it makes sense to look at some single animal to understand how this animal evolved, but you should always be aware that there's lots of details which you're actually not aware of, because you would need to know the whole environment and the whole development in time of the whole environment to really understand what drove the evolution of a certain animal in a certain direction. There's another kind of related possible misconception about evolution, and that is, there's this nice statement of the survival of the fittest. And in certain contexts, this is kind of taken as a survival of the strongest, which is not correct, because what it means is that the entity that adapts the best to the environment, which includes, of course, all the other entities, be it animals, plants, or, for example, in the case of society, the other people and companies and things like that. So the entity which adapts best to the circumstances is the one which will keep on developing. So basically, if you look again at biological evolution, everything that is alive today has been the fittest up to this point. This will change because everything is changing. And at some point, certain animals will vanish because they just are not, do not fulfill this requirement of being fit for the environment anymore. But that doesn't mean that they are strong or anything like that, or that they are in some way better than some other entity or organism. It just means they're the best adapted to the circumstances they're living in. If we go back to the cat, if you take a cat and throw it in the sea, it's not very fit to survive there, so it'll be a problem. It is quite fit to be, to live on a farm, so it's very well adapted to this, but it's not adapted to live in the water. It probably also wouldn't be adapted to the tundra 200 million years ago, because it probably wouldn't find the right animals to hunt, and it would probably be hunted by certain animals, and I don't know if that's true, but it's, you cannot just say they're better than the animals that lived 200 million years ago, because the animals 200 million years ago were adapted well to their environment, and a modern cat is probably not. So that is something to always keep in mind. So this concept of something being fit, it's actually very context dependent, and it's not a judgment of value. It's just a statement of the fact that if they were not fit to the current environment, probably they wouldn't survive the environment much longer. Let's say it like that. Which, if you think about it, also is the reason why the climate change we see at the moment, which is on a faster pace than usual in Earth's history, of course will create the problem that many animals might not be fit anymore to the environment, because they might not adapt fast enough. And we already see that we're losing animals, and that is because of those changes in the environment, which to a certain degree we are causing, not just with climate change, but also with destroying natural habitats for various reasons. Now, once we have this general understanding of how evolutionary processes work, how can we use this to analyze things that we see around us? The first of all is, as I said, to realize that there's many evolutionary processes which work to some degree similar to biological evolution. For example, you can look at the evolution of society. Of course, we have our own field of study which does this, which is history. And you can see that historians actually, they look at different influences. They don't just say, oh, there was this ruler and then this ruler and then this ruler, which probably in the past at some point they did, but a modern historian would most likely find that pretty boring, but they actually want to see how things develop and what influences created new developments in the society over time. And this is an evolutionary process. And here it's not animals, but it's different people, it's different institutions. And you can see that different institutions change over time. And they lose functions, they gain functions, they are replaced by other institutions. And you can also see that people react to those things, like our modern concept of work days. It's something which to a medieval farmer would have been kind of stupid as a whole concept. only when new entities formed, which were kind of created factories where machines were running and where certain methods of production were used, did it make sense to kind of structure the workday in this way by time, and so that this developed at that point. And you can find many examples, and if you are interested in history and you kind of try to learn about different times in history and then see how did things develop from one step to the next, and then you can actually see there also is a huge interconnectedness, much more than we usually think when we look at history. And you can also look at the concept of survival of the fittest, not in the sense like the philosophical school of social Darwinism did, which basically said it's the strongest who survives, and just focused on, basically, actually they more focused on saying, oh, there's just some losers and so they're bad off. And this is not what actually evolution is about, or also not what Darwin said. This is something, a misuse, basically, of the idea for ideological purposes. Because if you really think about it, everyone adapts. It's just, for some people, those adaptations are not very useful and they suffer. And so, looking at the development of things like society, you can see there is evolution going on. And you can, the problem with evolution is you often can only understand it backwards. You cannot, you can kind of map possibilities, and you can say certain things cannot happen, but you cannot say, I know what exactly will happen, because the process is just too complex, and you will probably never be able to see everything which influences it. Our societies are also influenced, for example, by weather patterns, and over time, climate changes that appeared will have changed societies. New diseases will have changed the society. So there's those outside influences. At the same time, for example, the fact that we now live in larger cities. The larger groups of humans you have, the more diseases can spread. And this is something which, for example, for a hunter-gatherer society wouldn't be a problem, or is less of a problem. And which is also how we can see that there's a risk whenever a hunter-gatherer society meets people from a more city-based society, simply because the people from the city-based society have other germs they carry there which those societies would not have had to face in the past. And also, if you take this kind of view, you actually arrive at the point that it also doesn't really make that much sense, at least from a view of evolutionary processes, to kind of say one culture or civilization is more developed than another, because, I mean, also a hunter-gatherer tribe, which is probably now still existing in the Amazon, for example, they're as fit to their environment, at least as fit as a modern Western person is to their environment. So it's just a question of how well are you adapting to the environment around you, and how well can you adapt to changes around you. There is one further idea, which I think is quite important, which also influences how we should look at our society, and, for example, which is important to understand when people think about policies to reach certain goals. And this idea is that there actually is not only this kind of natural evolutionary processes like I described them, but actually there is also a way to influence these evolutionary processes, which, if we go back to the cat, that's kind of what happened. I mean, humans influenced the development of cats by making them their pets, and the same is true for dogs, or the same is true for the plants like grain, which we have cultivated over time. And this didn't just happen in one step and once someone snapped. And when it started happening, the people that started it couldn't know where they would end up. But what they did is they said, okay, we'll try to kind of pick what is the best for us, and then this way you can kind of drive an evolutionary process in a direction which you want. And the same is also true if you look at for example, evolution in society, or also other evolutionary processes in nature. You can kind of try to nudge it in certain directions. You will not know what exactly leads to it, but you can influence it. Which, for example, I personally feel that this is not done enough in many economic policies, or also in policies how to deal with climate change, because there's this idea that markets are self-regulating and will lead to certain results. But actually, if you look at markets, they're very evolutionary in their process, and if you just don't influence them, then they might end up anywhere. So you should actually influence the environment by some way, some kind of regulation or incentive, to kind of steer the development or evolution of markets in a direction which you feel is a good way to go. And that is probably at the moment not done enough. If you look at history, there were always times in history where this happened. And often those people who did this well, they created amazing results towards what was their goal. And of course you have to do it well, and thought out, and know where you want to go. So I'm not making any explicit political suggestions. It's just the idea that this kind of policies can also be looked at from this kind of point of view of those evolutionary processes. Maybe as a last aspect, which I should have probably mentioned earlier, but one thing to consider is also that different entities evolve on different timescales. So if we go back to organisms, it is just the fact that different organisms have different reproductive cycles. They have different their speeds in a way, and of course changes usually happen with every new generation. So, for example, we see that that viruses or bacteria, they evolve very fast because they reproduce very fast. Well, for example, to have a genetic change in a cat, well, where a virus evolves within weeks, a cat needs a couple of years before it can have children, and so very small changes just in every generation. So changes in a cat would take many years to happen, and probably in some trees which have much longer reproductive cycles, their changes there would take an even longer time. So this also, of course, influences things, that you have to look at, okay, different entities evolve at different speeds. In society, you can see like a big company changes on in much longer times, or needs much longer times to change than does a freelancer, for example. And both have advantages and disadvantages. It's just to understand the evolutionary process, you have to look at, okay, the ones that adapt faster are interacting with others that adapt slower, and this, of course, also is an interesting part of the whole dynamic. There is in nature actually some tricks of slower organisms to compensate that they evolve slower. Our immune system is a trick. Our immune system, like we humans, as the species human, we evolve on a time scale of, we need at least around 20 years to generate the next generation, I would say. On average, you usually say around 25 years. So you can see, okay, like big changes will need many generations, so we evolve quite slowly in comparison to viruses, for example, which evolve within weeks. So our trick is to have a part in us which actually also is adapting very fast. So in a way, you could argue our immune system actually is mirroring the evolutionary speed of the viruses and bacteria it's fighting against. And you could, for example, also imagine similar things within states, state bureaucracies, or within companies, which kind of try to react to those things. And I'm not deeply enough in all those structures to say what exactly those things are, if they exist or if they need to be started. But it's an interesting thought that those are also further influences on how these processes happen. So I hope this were some interesting thoughts for you. Maybe when you look around you and try to understand how did certain things develop, it is helpful to say, okay, can I understand the evolution? I often find that things which I think, which I'm not very happy with, developments, for example, in society, I can completely understand how we got there without anyone having any bad intentions, just very many small steps driven by some outer influences. And I think if we want to change, for example, those things, it's better to understand how they developed. Other cases, it's just interesting out of curiosity to look at how biologic evolution worked, or also on a larger scale how the geology of the Earth evolved, how stars evolved, galaxies and things like that. So I think this is a very powerful tool, just as a general way of thinking. Of course, in the particular cases, you have to go into much more details and look at much more things. But as a general pattern of thinking, I think it's extremely useful to use this. I personally use it all the time to kind of understand how things got to a certain point, and I encourage you to do the same. So I think that's enough for today. As always, if you like this video, feel free to share it, to like my channel, to subscribe to my channel. I'm also always happy about feedback, so if you have any ideas to improve the videos, if you have any subjects you would want to hear my opinion on, please be free to contact me. And so I'll end this. As always, I hope you're well. I wish you to stay healthy and safe. And until next time, goodbye.